Alrighty, good morning everybody and welcome to the Wolf SSL Live webinar, wolfTPM Roadmap and Best Differentiators with Wolf SSL engineer Dimitar Tomov. My name is Kajal Subkota and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you would like to ask the question live, as we will host a Q&A session following the presentation. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite everyone to follow us on Twitter at wolfSSL, as well as all of our other socials. And please feel free to email us at facts@wolfssl.com if you have any additional questions. And now I think Demi would like to give a short overview of the presentation.
Hello, everyone. Thank you, Keja. So I wanted to give you an idea what you can expect to learn today. There are three main things. One is why is DPM so powerful and why it is so useful, and we are seeing rising adoption of it. The other is how wolfTPM makes that easier and simplifies that, makes it quicker to develop. And this is thanks to three strong sides we have: the design, the APIs that we have, and the many examples that we have. And then the focus, of course, is on the roadmap for 2021. What new things can you expect in wolfTPM to accelerate these advanced use cases for better security? And back to you, Kaja.
Yeah, thank you so much, Demi. Now, before we formally begin, I'd like to give a brief company overview before the technical part of the presentation. Wolf SSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source, dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2021, most of which are engineers. This progress is of course supported by a strong partner network that we're proud of, which includes Microsoft, STMicro, and Curl, for example. Since the beginning, our engineering team has developed several embedded security products, including WolfCrypt with DO178 support, FIPS certification, and a FIPS ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as WolfBoot, as well as Java wrappers and JSSC support, and commercial support for curl. All of these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Demi.
Thank you, Kajal. And this is a really great overview of the products that we have. It's very nice that wolfTPM is also integrated with the Wolf SSL library and our secure bootloader, WolfBoot. And there's something new coming for this year. So really quick overview. There are many major things that happened in 2020. So I've gathered some of the highlights. Some of you might be already using wolfTPM. We have many customers. Others might just learn about this new TPM 2.0 stack. Some of the highlights of 2020 is that around the summer, we added native support for Linux. This means that you can use any TPM the same way. The Linux kernel takes care of the configuration, and you have all the APIs of wolfTPM to do your use case. Then we added dynamic module detection for those of you who do bare metal projects and embedded systems. And we have most of our customers are bare metal and embedded systems. So timings, wait states, we know that sometimes that's trouble configuring. So by adding this dynamics detection, we solved that problem and made it easier for people adding TPMs to their embedded systems. Then the other important thing that happened in 2020 was that we also added native support for Windows. This means that using wolfTPM under Windows is the same as developing under Linux. To the developer, the API is the same, the functionality is the same. And to even make things easier, there is also now TPM simulator support that helps you debug your application and your use case of a TPM very seamlessly on your station. This is especially useful for, again, people who are doing embedded systems, IoT and edge devices, to just be able to extract that portion of your project and work on it. It's really useful. I've experienced it myself. Another major milestone, and that has been requested a lot by our customers, is the protection from man-in-the-middle attacks. Because the TPM is really good as a protection model, as a secure chip, but there's still one attack vector, and that's the communication between the TPM and the host. And that could be an embedded SoC or a CPU of a server. And for that, there is a capability the TPM offers, parameter encryption, and we support that. This capability allows the encryption of the first and most sensitive parameter of the commands of the TPM that's supported. In this, that's really important. So we added also new wolfTPM wrappers to help that. We also added HMAC session support that adds extra layer of security into the communication with the TPM. And to use this, again, I want to emphasize it's seamless to the developer using our new wrappers. And we really focused in 2020 and want to continue in this year to add more examples and show how to use these wrappers more and more. We have examples for attestation, secure key generation, and we'll talk about this later. So I want to also highlight the design qualities that make wolfTPM stand out. One of the reasons it has been so successful is because all of Wolf SSL products have been designed for embedded use first. This means that they have to work in constrained environments, memory-wise and performance-wise. So this means that by having wolfTPM designed in such a way, it can run on anything and everything. If you can run on a constrained MCU, then it's easy to run the same application on an 8-core i7 or 32-core ARM v8 or a PowerPC, Power 9. And that's really important to emphasize that this is also helps to the developer because it has a minimal code base. It's really easy to go through the code and find what you need. And I'll show that. So we have two APIs. The one is the one-to-one mapping with all TPM 2.0 commands. We support all TPM 2.0 commands. This is typically useful for people who are already familiar with the TPM. We also have our wolfTPM wrappers that on one side speed up development, on the other side, they help development by making sure that there's some kind of improper configuration, let's say with the TPM sessions. So we recommend using the wrappers, but for those of you who want more advanced use, the one-to-one mapping native API is available with examples. Then naturally, parameter encryption. Again, we have wrappers to help use that in your applications. And the emphasis on examples, it's really great that we have many use cases covered already. Then on a transport layer, so TPMs typically work using SPI and I2C. And for bare metal scenarios, the only thing we require is a single IO callback. We support many platforms already, but in case that your platform is not supported, it is as simple as just configuring the interface and providing that IO callback for read-write for sending and receiving bytes on that interface. Because we use the standardized TAS transport interface specification for the TPM, you can attach any TPM from any vendor. It should work the same way. On Linux, you have two choices, using the SPI def or using the native Linux support for def TPM. Um, it is recommended to use the second one just because it takes away the configuration hassle, but having the SPI def is also possible, and it takes just a few lines of configuration if you prefer that, or you have some limitations on your embedded systems that require you to use the SPI def. For example, you have multiple devices on that same SPI. Windows naturally supported. It's just one configure switch, and it works out of the box. Then for embedded users, we know it's important to have support for the most popular and most used hardware. So we added Raspberry Pi support, and there are TPM 2.0 modules that could be ordered to add to your Raspberry because it doesn't come on the board. It's just a header that you can attach. Then the STM32 MCU series is very popular, and we support that through the ST-CubeMX framework. I'm sure that those of you who are using STM32 are familiar with that framework. In any case, if you have any questions about how to integrate with your platform, make sure to just drop us a message at support@wolfssl.com. We're especially interested in if you have a microchip platform that you're using, because microchip are already providing licenses for wolfSSL to their users, and just adding wolfTPM to enhance your security, it's seamless from the developer's point of view, because there is already integration between wolfSSL and wolfTPM, as well as wolfboot. That's our secure bootloader. And a highlight on the Xilinx XanQ, which is a hybrid SoC. It's FPGA and ARM CPU in one. We also support that. Then on the modules, we're already working on supporting new ones that we expect to come in this year and next year, because the specification evolves in few years, and we are already working on that to make sure that we support all the latest. I want to emphasize that you can use any TPM from any vendor. It should work the same way. Then on the examples note, we take pride in that we really demonstrate through open source how our products work, and it's really easy to just go and see the code and try it out. There are examples for the most common cases that we faced, and for the bit more complex ones, like attestation and the use of the TPM's platform configuration registers. Those are special registers that can be extended hashes into them. And through this, you can do measurements, take state of a system, like a snapshot of the state. And that's really useful. I'll talk a bit about later. Another example that's very common and people I know use it a lot is the TOS client server example. Certificate signing request as well. It's something that people want to back using the hardware security that the TPM can provide. And we added benchmarking that, as far as I know, no other stack has, for those of you who have some latency concerns, because the TPM is a cryptographic module. It is not an accelerator. It was designed to provide guarantees for security, not performance. So that's important to mention. Now, why the adoption of TPM is rising? Well, on one side, it's commonly available in x86 systems. It provides measure boot and a secure vault for secrets, mostly key storage. But we're seeing this continuing trend from the last 2 years, maybe 2 years and a half, that more and more embedded systems are being designed with TPM on them. And one of the reasons is, of course, to provide better protection of the TOS connection that uses encryption keys. And on the other side, we also see a lot of encryption solutions that go into devices in the field that are exposed, and the TPM is physically tamper-proofed. So there are many aspects of why a TPM is a useful tool to your security. Of course, it depends on your concrete case, and that's why it's also good if you're considering adding a TPM to just send us an email at support, and we will look into your concrete requirements. The new trend that we are noticing, we noticed actually in 2020, was that more and more automotive projects are adding TPM for vehicle-to-vehicle communication and V2X, that's talking with smart city and other infrastructure, as well as infotainment. Also, it was very nice surprise to see high applicability in aviation projects. The adoption there, it has been great. And medical devices, various devices that go into hospitals, that's important for all the data they have. They also turn to TPM for security, as well as new railway systems. So safety critical systems in general took a sharp turn to adding TPMs in the past year. And the reason why that is so, from what we can see, is the key generation and storage capabilities of the TPM have been the most predominant use case, because the TPM can generate keys that only it can use once loaded. And when they are not used, they're staying outside in protected form, encrypted. And this is really good for devices like Edge and IoT that are in the field, and someone could indeed physically try to break in, tamper, and get access to. So even if they do, well, they'll have a difficult time getting that secret and using it. So another great thing is the non-volatile memory. As I mentioned, it can be used as a secure vault to store arbitrary data, user data. It could be configuration, it could be something else that's up to the user, up to the specific product and project. This is actually a very interesting feature, and some of the vendors are addressing that with adding more non-volatile memory, as we will see later. Then the other interesting scenario is the use of the platform configuration registers, the PCR. They're really useful for taking different measurements of the system, and having those can be of great help for auditing purposes, keeping track of the state and health monitoring. There are also PCR policies that could be added based on those PCRs. And based on those PCRs, we can unlock keys and parts of the system. And this is one of the more complicated cases I'll talk about later. So the TPM has been around for, I think, 3 decades at least. And the previous version of the TPM 1.2 came about 2005 and has been deprecated. You would not find it in new systems, and it's not recommended for new designs. The TPM 2.0 is the current version. It's the one recommended for new systems, and it's what you would find in almost all manufactured modern computer systems, really, even in embedded that come with TPM. And it supports a lot of algorithms. Some are optional. The most common are the RSA 1024 and 2048, as well as ECC P256. Naturally, the TPM supports hashing algorithms. SHA-1 is deprecated for obvious reasons. It's no longer secure to use, safe to use. SHA-2 and SHA-3 are supported in hardware, and that's really useful. It's also, SHA-2 is the algorithm used for the PCRs, good to mention. So this is just a brief comparison. The TPMs do differ a bit internally, the CPUs they use, but it's important to mention that they are FIPS certified. We have customers for whom this is important. So I want to mention this. And also here the highlight on non-volatile memory, the ST variant of TPM 2.0 comes up with over 100 kilobytes. And this is because, as I mentioned, there are indeed a lot of cases when you would like to store some kind of a secret or just important data that you would like to protect using the TPM. It's especially good during reboots, power offs, and in general. So that's an interesting difference between the TPMs. As a performance, this is just to demonstrate that you cannot expect great performance from a TPM, but it's not really the purpose. The emphasis is on security, and these algorithms this is done in hardware, and it's protected from side channel attacks. So because of the way it is implemented to make those guarantees to protect from side channel attacks, it is slow. But again, the emphasis is on providing you the security that your operations are protected. Actually, it's not terrible. It's really a matter of latency. In most cases, we don't see a problem with latency, but for the people who are concerned with that, we have some benchmarks that we can share. So reach out, and we'll be happy to provide those. Then for this year, the what we've planned is really to address one of the cases that we see to come up with embedded systems, is that more and more open SSH and SCP is being used. Unfortunately, OpenSSH integration with the TPM is complicated. It's really difficult to set up. Right now, we can go to Google and we'll come up several articles and blog posts about describing how to configure that. It takes 4 or 5 pages of instructions, and it's not guaranteed to work. So we want to address this. We want to help our customers, and the integration between wolfSSH and wolfTPM is our first goal for this year. The idea is that the connection could be really better protected by having the keys backed by the TPM and used through that. And we already have a great example of this kind of integration being really successful. Wolfboot uses wolfTPM to provide secure and measure boot, and that has been really beneficial to increasing the level of security. Also, we have commercial support for our customers. So any kind of specifics or add-ons and features to wolfSSH or SCP scenario could be addressed. And we are open source as well. So having this tool combined with the TPM, we see as a great fit. The next thing is adding new examples, because wolfTPM right now supports all the TPM 2.0 commands, and making that easier to use is by showing how to use it. And one of the cases that comes up is sealing secrets. So there are 2 ways to do this. So we've targeted to add examples for both these 2 cases. The one is actually sealing a secret that's limited up to 128 bytes into TPM generated key. And the good thing about this is that only the TPM can read that secret only when the TPM key is loaded. So in a sense, you can read out the secret only if you can authorize properly the TPM to load that key. And this is very interesting use case of storing small and short secrets. There are various applications of this. The other example is a bit more complex. It's very similar to how Microsoft BitLocker works. That's probably the most popular use case there is of a TPM. Any Windows user probably have faced this when they start their PC and they need to enter a password. That actually what it does is it unlocks a key using the TPM, and that key is then used to provide access to the system. So similar protection that Microsoft is giving to their users could be done using wolfTPM. It's already possible. It's a matter of putting the things together, and we want to show an example of that. We want to make an example of that that's easy for customers to just take and use. Continuing with the emphasis on more examples, because wolfTPM offers all the capabilities of the TPM, is addressing this non-volatile memory use case. And again, it is a matter of really, if you have some sensitive data that you would like to protect between reboots, or just to make sure that it is protected when your device is in the field or in a hostile environment, or you have concerns about just the software, the other software components that you're using, and you want to protect that's a really good place to have to be able to store secrets. And that's something we will also want to address. And for some of the examples that we have, I wanted to talk about the combination of wolfboot and wolfTPM, because we are seeing this adoption of secure boot, and there's something more that can be done. I just want to show this diagram that I made. So having secure boot means that there is a signature to the image that you have of your firmware or your software or your configuration. And having that signature gives you a way to verify before you actually use that firmware, before you actually apply that configuration. And that's great. What the TPM provides extra is that this information can be passed on to the application that follows. Also, this can be a cyclic process, meaning that once you do secure boot, you know that your system is in a good, healthy state. You've booted a genuine firmware. You're in a good configuration. The moment that has happened, there is no more guarantee how the state of the system changes until you reboot or do firmware update. And this is where the TPM is really useful. Using the PCRs that can be reset only on power on means that we can extend hashes of different parts of the system or files and provide measurements, provide status of our system throughout the runtime, throughout the life cycle of the system. And because the PCRs can be resetted only on power on, in most cases, there are some special PCRs, but most of them are protected and can be reset only on power on. This is very useful. So your application could first check in which configuration am I running, and I'm sure that this information is not tampered with, and then decide if I want to execute one way or another, or in which mode have I booted. And this is really useful. So we support both of these through wolfboot integration with wolfTPM. Another thing that's very often the case is that the TPM is really good for backing and a TOS connection and certificates use. We have also the way of connecting the crypto callback, the Wolf SSL to call the TPM callback, and just use that as a backend. Then the complicated use case that I want to focus a bit more is the attestation use case. And this is where I want to emphasize that having this complexity around TPM is taken out when we use the wolfTPM wrappers. And what we have, I just want to show right now, just an example. I think that would be best. Or maybe, Keijo, maybe we should first address some questions, or I can just show the demo.
I think let's move on to the demo, and then we'll address all of the questions at once.
Okay, sounds great. Just one moment. Yep, let me go. Just one moment. Okay, so yeah, that's okay. I have some technical issues. Bear with me. And now you should be seeing everything there is, right? So I'll just go into the wolfTPM folder. I hope that's good to see. I'll check what branch I am. Okay, I'm on master. I can show you the tags that we have. Here is the v2o branch. I'll just check out for live demo, and we do that. And from here, we do a configure line. And as I mentioned, we have the TPM simulator support, which means that we can observe how the packets are received and what are we sending in case there is a very complex case. And this is really fast, as you would see. And here you have a nice summary of the configuration. And you can see here, software TPM is the chosen configuration, quick make, and we are ready. Here we go. And because I'm using the simulator, I need to start it naturally. So I'm doing that right now. And I can show just how easy that is. And there we go. We have a socket open that wolfTPM will be talking to. And from here, if you go to the examples folder, we have a nice README explaining all the examples, TOS examples, and so on. So what I want to show first is one of the more complex examples that we have, and that's the timestamp. That's really one of my favorites, really. So the signed timestamp provides you interesting insight into the system. It gives you how many times your system was resetted, and so on. And in this case, I just wanted to show, for example, I noticed that this wrapper is used right here, wolfTPM to dash underscore PATK, and I can just do grid grip. You don't even need a complicated editor, and I can immediately see that this is used in two examples, into the quote example that's getting a PCR and generating a report for me, auditing report that I can use for my system. And I can look into the source code of these examples and figure out how exactly to use it just straight on. All these wrappers are actually located into src-tpm wrap.c, and you can go through here. And if you notice some kind of a wrapper that you want to see how to use that, it's a matter of grid grip. Another thing I wanted to show is the key gen examples. So secure key generation, key storing, and importing keys that have not been generated by the TPM. That's often as well a question. So we have these three examples here: key gen, key import, and key load. So the first example, if you type -h, you get a very nice help. And what it would do, it would make some assumptions. If you just run it, it would generate a key with RSA for you. And we can enable also parameter encryption. Okay, that's probably something, let me see. Okay, and in this case, we have this blob generated, and that is ready to be loaded then to the key, and we get a nice handle. So first we get a handle for the storage key, and then here we'll get a handle for the key that was actually generated. So both of these keys are loaded into the TPM and are used from there, and that's the really good thing. The other thing is that, let's say we have a key that is not generated by the TPM, then we want to import that, and this is also possible through this quick example here. And what it does, it will give us another handle for that. And I would just want to show the source code to show that what it does really is it uses some test keys that we've created that are, maybe I'm too fast, I just want to show. And this is being loaded to the TPM. And in this case, if I enable more debug printout, I can even show you, I'm not in the right folder. I can even show you some of the TPM2 commands and also wolfTPM wrappers that are used. And I can just walk you through really quickly how easy it is to orient. And as you can notice, actually building the library and using it, it's really quick. Configure lines are simple. Enable software TPM, enable debug. In the case of a Linux, it's TPM def, and we have that. In case of a Windows, it's enable TBS, I think. And yeah, there we go. So now if I run the same examples, let's say I run the key gen example. So key generation, and I run key gen. Maybe I need to clear actually the TPM simulator. Let's see. Okay, we don't. So we get actually the TPM 2.0 command, and we get a bit more information. For example, we get this native API, TPM2 read public, which is to load the already existing storage key that we have. And if I do a git grip, just to orient myself, where is that used? We can see we have native tests. We have it used in the PKSS7K example, and so on. Also nice is to mention the new wrappers we added for starting TPM sessions for parameter encryption. And you can see that's being used in keygen, key import, key load, quote, sign timestamp, TOS client server, and all of this is just out there into the source code, and you can just look at it and see an actual use case, and not just one, several. And you can see how to do that. And what I mean is that, of course, the line here looks similar, but the lines above that, we can look and see how they differ and see different use cases. Just real quick. We can see different use cases of parameters, and the code is really streamlined. It's a matter of there we have a wrapper, create and load attestation key. That's a wrapper that does a lot for us, and it's straightforward to use. I want to just show that as well. So let me see. Yeah, there we go. We have it used in the quote example, in the sign timestamp example. And if I just show you, and this is where I'll close the demo. into the wrapper case, that it really, what it does is it uses another wrappers to get different templates depending you want RSA, ECC, then it calls another wrapper, and it's really seamless to follow and use. And the create and load key, actually, it uses the wrapper for create and loading, and all of that, it really helps to speed your development and make sure that the steps to use the TPM are correct. It's all a matter of these parameters, and you have the examples to see how to set them. I think it's good now to turn to questions.
Alrighty. Our first question is, do you support Intel PTT or firmware TPM?
As long as this is exposed, it depends on the environment. If this is Linux, then this is a Linux-based embedded system or Linux system. This is exposed from the kernel. So if it is exposed from the kernel, then it is really a matter of just using it as any other TPM, really. So it's really a question of what is your environment. I would recommend just contacting us at support and telling us a bit more about what your environment is. If you're learning Linux or Windows, then this is just native support. You just do configure, enable devTPM or enable TBS. I can show it right here. Give me a second. In the transport slide. So just one of these on the configure line, make, and you can seamlessly use it. So my answer is yes, we support it. The only scenario that I can think of is, and it's really a corner case, if you're running bare metal on a x86 machine, but that's highly unlikely. So in Windows and Linux, in both scenarios, yes, we support firmware TPM from Intel PTT.
Awesome. Do you have an API for accessing the TPM event log? Windows has one, but they're not sure if Linux has one.
That's a good question. That's definitely something we can look into. Right now, I don't think we have such wolfTPM wrapper, but we can definitely make that happen. That's actually a very good suggestion. Thank you. I would, again, I would want to hear more about this. If you would be so kind to just reach out after the webinar, I would like to talk about this, because this is actually a good idea. This is a very advanced use case, so not many customers are interested into the event log, but this is related to the secure boot and measure boot and just upgrading over that. So I think there is there's a good reason to add that.
Awesome. This question comes in a few parts. So the cryptography in TPM is done in the actual TPM chip.
Yes.
What is it that the wolfTPM code does? Is it providing a uniform API to the multitude of hardware devices and operating systems?
The simple answer is yes. The way it does it, it's what's important, because the way the TPM works, it uses this TIS layer, right? And we have, and the TIS layer, it uses various registers of the TPM. So to get to this, there's a long specification. What we've done is created a stack that's lightweighted and easy to use. And also we pride into having API backward compatibility. We are the only ones that have that. We don't break API. What you've built today will work tomorrow, the next year, the year after that. So the answer is yes. The TPM has a standard interface that requires a lot of managing. So what we've done with our code, with our stack, is actually taking that out and just providing you with this unified API to use any TPM in almost any environment. So the answer is yes. And without a stack, you would have to code the TPM commands directly, and they are comprised of so many parameters. It is possible. it's just I would not recommend it because of the complexity and the chance to get something to just the the consumption of time and would be so much. Let me just try to TPM to create. Yeah, for example, send command alt is a very important command. This is the way to send commands that are authorized and come with, let's say, a session or a parameter encryption. So to have this command, this would mean to create all of this and make sure that all of this is followed and handled. So yeah, that's exactly what we're doing. We are providing a seamless layer to talk to the TPM. Otherwise, it's a lot of calls and functionality. Yeah, and actually, what I could show probably is just I can go wiki TPM. Uh, so I can just go TPM software libraries. The one thing is here that we have this mapping to TPM commands and wrappers. Wow, the other stack that typically people use, it has so many abstraction over abstraction over abstraction, and we're just wrapper, just one layer, and we run on bare metal while the others don't, and we're lightweight. So that's I guess the big differentiators. Since this is the title of the webinar, I thought it's good to mention that.
Alrighty. Is the parameter encryption part of the TPM standard and goes all the way to the hardware? Or does it only cover the path between the applications and the wolfTPM wrapper layer?
It is in the hardware. It is a TPM 2.0 hardware capability, and we've implemented the support for that. So it provides the guarantee that from your application using wolfTPM, you have the guarantee that the payload is protected from your application to the TPM and back. There is request encryption and response encryption, and both are supported. It is up to the user, to the developer, to request either one. You can request only, so for example, in the case of creating a new TPM key, you can request to encrypt only the request. So what you do is essentially encrypting the password. For example, if you use password authentication, you encrypt the password to using the key. So even if someone captures this command, let's say you have an edge device and someone goes and just takes it and puts an SPI sniffer, even if they sniff that out, it's encrypted and they wouldn't be able to do much. And that's provided by the hardware. We added support to use that capability.
Awesome. Does the user have to explicitly manage context to ensure the TPM's limited memory is managed?
That's a good question. There is the in wolfTPM's case, you have the option to load and load keys seamlessly, and there is no resource manager. Interestingly, though, in most cases, we see that the two key slots, the DPM has only two key slots physically to be loaded keys at the same time. And we see that that's sufficient. We had a very interesting customer request that they really wanted to exchange a lot of keys. And once you realize that actually you use a key for TOS connection, and then that key is kind of the majority of the time the one you use, and the other keys you use infrequently, you use from time to time. So changing those happens very rarely, and adding resource manager is adds complexity. So right now we don't have that just because our customers have not experienced the need for that. But if that's needed, we could add that. So right now there is no support to exchange keys. As for the context, we have some TPM context already managed by the stack for the developer, for the user. So you don't have to worry about stuff like TPM sessions and such. Uh, Perhaps it's good to tell about more requirements and reach out after the webinar to tell us more, and we can address those. I mean, I would personally would like to learn if there is a need. We can definitely address that.
Uh, awesome. What is the PCR and what is the PCR underscore extended or extend?
Good question. I may have skipped on that. So the PCR is a special register memory part of the TPM hardware itself. These registers, they are actually we can go into our documentation. I think that would be nice also to show that we have nice documentation on that is good to use. I just hope I'm good at finding that real quick. So I think it's into the quote, into the PCR. I hope so. Yeah, there we go. There we go. So into this here into our GitHub repo, you can find a lot of information. So the PCR is a register that provides a lot of there are 24 typically, that's defined by the standard, and you can extend hashes. And the way you extend hashes into these registers internal to the TPM are that they cannot be overwritten, they can be only added. There is a computation that happens. So the only thing you can do is you can extend forward, you cannot go backwards. The only way to go backwards is actually to reset. And the reset happens only on power on. So the extend is a cryptographic operation that allows you to have deterministic values in the PCRs. Let's say you make a hash of your server or your Docker config file. Then that hash is extended into a PCR. This PCR is now tamper-proofed. It can be extended forward, but the value would no longer match. So this way you can provide this kind of assurance for others to use or for yourself to make sure that you're in a good state. It is a really one of the advanced cases, and we have these examples of PCR reset, extend, and quote, which essentially takes the PCR, puts it in a signed structure, and you can use that for reporting, auditing, monitoring.
Awesome. Is it possible to configure wolfcrypt to use wolfTPM or for some of the other cryptographic operations?
Yes, there is integration between wolfcrypt and wolfcrypt and wolfTPM. As to the extent of what is supported, I'll have to turn to our colleague David. But there's working integration, and that's being used by our customers between wolfSSL and wolfTPM, including wolfboot through wolfcrypt, and wolfTPM is doing that as well. So there is definitely support and integration working. It's more of a question of what kind of algorithms and your concrete case.
Cool. For the live demo, was a simulator or a physical TPM being used?
So for the live demo, I used a simulator because I'm on Mac, and the Mac doesn't have a TPM. But if you would want, I can actually real quick, I can just I can show you real quick live demo of a give me a second of a. So I have an ST32F4 connected right now, and on that I have a TPM connected. So this is live to the board, and I can just go and I show you one of the new wolfboot examples that we've been working on to demonstrate measure boot. So here I'll just do ARM GDB. Give me a second. Okay. So here is the OpenOCD working, and I'll just connect over, and I'll reset the target. I'll add. I already have the wolfboot loaded, so I'm loading my application symbol file, and here I can break into main, and you see that I have two main. So the first one, we boot into the bootloader. There we go, and here's the wolfboot TPM2 init. So I go into that, and here's the SPI init, and I'll just exit from this function. So it's initialized, right? We have the wolfTPM 2 init, we have wolfTPM 2 capabilities, and that's actually working on the real hardware. And here we get the wolf boot start. So that's also starting. Here we have some checks. I'll just go over those. So we enter the application. So this is actually a measure boot happening right now, and that's measure boot. And the way I can also show you that is I can do measure boot. I can break there. Of course, I need to reset the board again, and maybe I need to reset the TPM, power on off. I mean, to do that. So let's see. There we go. We are in measure boot. So what we will do here is we'll go through, and there we go. We have a PCR register selected. We choose our hashing algorithm. We'll be extending only one PCR, and what we'll be extending, one moment, and what we'll be extending into this is actually the digest, the hash that we have of our own image. And that will be available later on for the application to use and know in what state the system was when it was booting. And that's the difference with secure boot. It's really useful.
Is there example code for talking to a Raspberry Pi that has a STTPM module on it?
Yeah, sure. So what you need is just one single entry into your Raspberry Pi device tree file. And from that, and I think we have that in our documentation, and from there you just run the examples. It's just a matter of, let me show again real quick. So I'll just go here. It just, let me make clean. So you just configure enable devTPM. I hope you can see that. And that's it. You do make, and it should be working out of the box. It's just a matter of single line into your device tree file. If you have troubles with that, please don't hesitate. Just contact support, and we can help out for sure. We do support Raspberry. It's just a matter of device tree configuration. The wolf boot, the wolfTPM just works out of the box. Linux kernel TPM device. And we have ST support as well. This is for bare metal. This says no because this is for bare metal when you don't have Linux. You'll see here, yes, yes, yes. When you have Linux, you just see yes here.
Fantastic. Could you show an example of using NVRAM to store data?
Thank you for this question. I'm happy to show you our testing that we have already into the code. So when you go to examples native, we have these native tests, and there we have some NV usage, but that's actually one of our targets for this year. That's one of the things we identified. This is useful to have. Just give me a second. So we don't have specific examples. If you look at our examples folder, right? We have benchmark, certificate signing request, key generation. Management is actually flush, to be able to flush everything that's in the TPM, like keys you've loaded and stuff like that. Native is the test that we have, PCR. So there's currently, I would very much like to have NV or non-volatile, right? So we have specific targeted examples. What I could show right now is the native examples that do show. What I can also show is that we do store a storage key into the NVRAM. I think. Give me a second just to think. Keygen.c. I think it was. Give me a second. So we support that, and we are using it. It's just a matter of. Let's see, we have the wrap tests, and we have here in the wrapper, we do have a wrapper. We have a test for that in the native test as well. So we do read from non-volatile memory here, but there's no specific test that I can show, just a specific targeted at that. It's just part of the native tests and the wrapper tests. And this is exactly why We will have that in our roadmap to add these tests. To address this, please just uh, send us exactly what you need and we can address that. I'll be happy to make an example for that, for your particular NVRAM need. And what I can show probably is the native test. I just need to recompile, but I see that we are already at 3 minutes before the end. So what I can do is to quickly show you that part of the code. I guess the NV index is what's really interesting to see the code, that it's really straightforward to use, but we would like to simplify that really to have it in a way that is really easy to use, just you have an example specific to that. But I'm so happy to hear that indeed we've identified a good thing for our roadmap. Thank you. And make sure to reach out and tell us exactly what you need, and I'll try to address that with a new example.
Okay, I will ask a few more questions before we officially end this webinar, and the rest of the questions that we haven't had the time to get to will answer separately and send via email all of the responses to the questions. Okay. Do you support bare metal with Cortex-M microprocessors?
Yes. So we currently have out of the box hardware abstraction layer for STM32 and Atmel. It's a matter of single callback, a single function to add support for more boards. So right now we support STM32 and Atmel chips out of the box. Anything else is just a matter of a really small effort to add, because it's a matter of configuring your SPI or I2C, and then it just works. It's just a matter of SPI read, SPI write, and it's a synchronous interface. So it's really a single callback. Contact us with the model of your platform, the MCU that you're using, and we can address that. Happy to. The answer is yes. Yes, we support it. wolfTPM is designed for bare metal use primarily, and yeah.
Fantastic. Do you implement trusted boot, that is checking against good or gold measurements?
So we don't have trusted boot yet, because gold measurements, it's a matter of it's a matter of project requirements. How would you like to access the gold measurements, right? Are they provided remotely? Are they provided over internet, over Bluetooth? Are they stored somehow that the system itself can check, right? But I would definitely write down that there is interest in trusted boot as well. So we already have secure boot and measure boot. Trusted boot is the logical next step, and I'm so happy to hear that people want to use that. So it's really a project requirement question. We can do that. It's a matter of telling us how do you want your gold measurements to be stored and then sent.
Awesome. And this will be the last question before we officially end this webinar. If you need to encrypt or decrypt a very large file and the key is in the TPM, would you need to export that key outside the TPM to perform the encryption or decryption? Attempting to feed a large file into TPM over a SPI bus seems very unwise.
Yeah. There is so on the question of SPI bus, there is parameter encryption as to large file over SPI. So the idea is that to use the key from within the TPM. I don't think you need to export the key outside the TPM, because once you export it outside the TPM, then it would not be a TPM generated key. You can do that. The TPM can generate generic encryption keys. That's not a problem. The question is that the moment you generate a generic key rather than a TPM key used from within the TPM, then you lose the advantage of having the TPM. What typically is done, like Microsoft BitLocker does, right? It uses a key from the TPM to decrypt another key that's onto the system, and then use that key to decrypt the rest of the system, right? So you have kind of key hierarchy, and the anchor, the main key, the master key, the storage key is in the TPM. Then there's another key, and then you get the actual key used for decryption. And that's, by the way, that's the our roadmap for the um, for um, this example here. That would be that would be addressing that exact case. So make sure to reach out, please, because getting feedback is really a great way to develop further wolfTPM. And I'm so happy to see that we've nailed uh, the roadmap for this year. I'm really excited.
Awesome. Thank you everyone for attending this Wolf SSL webinar on wolfTPM Roadmap and Best Differentiators. As a reminder, this webinar is being recorded and will be made available on our YouTube channel shortly after the presentation. And since we have so many more questions that we just didn't have the time to get through during this webinar, we'll also make sure to follow up with all of the responses to the questions in an email shortly after this presentation. And I invite everyone to follow us on Twitter at wolfSSL, as well as all of our socials, as well as emailing us at facts@ or support@wolfSSL in case you have any additional questions, and we would love to help you. And thank you so much, Dimi, for a fantastic presentation.
Thank you. Happy to.
I hope everyone has a fantastic day, and we hope to see you next time.
Great day to everyone.